Welcome back. We're looking at nonlinear systems of equations trying to find the solution. And here's the second equation, a system of equations that is nonlinear. The first equation, we recognize its graph. It is a circle centered at the origin. And what's the radius? Remember, this is 5 squared, so the radius is 5. Okay, and the other equation is linear. And so we're going to look at that and see. I apologize for this system. It is not working at all for us. Okay, this focus is terrible. Doesn't maintain the focus at all. Okay. All right, let's try. Every time I move away, it loses its focus. Okay. There. Okay. Now, in this case, last example we used in elimination. Here, I think substitution makes the obvious choice because I have a y that I can easily solve and isolate. Y equals 2x minus 5. Okay? So what am I going to do with that equation? I'm going to substitute into the first equation. So x squared plus y squared equals 25, and I substitute. That gives me an equation in terms of x, and I should be able to solve that. It's a quadratic equation, so we know that we're going to multiply out and get 0 on one side and combine terms. So I get what? 2x, the quantity squared, minus 2 times 2x times 5 using our special product, plus 5 squared. Okay? And I'll go ahead and subtract the 25 to get 0. Okay, everyone follow what I did there? Just used a special product. Okay. And then I subtracted the 25. All right, so I get x squared plus 4x squared. Don't forget to square that as well. Minus what? 20x. Those cancel. And so 5x squared minus 20x equals 0, and I can solve that by factoring. So it looks like x equals 0 or x equals 4. Okay. Now how do I find the corresponding y value? I can go back to my substitution. Y equals 2x minus 5. So first of all, if x equals 0, y equals 2 times 0 minus 5, which is negative 5. If x equals 4, y equals 2 times 4 minus 5, which is equal to 3. So what are my two solutions? 0 and negative 5, and the 0.43. Now I want to check those. How do I check those? We came up with these solutions using the second equation, so I'll plug them into the first equation. So we're looking at x squared plus y squared equals 25. And if I use 0, negative 5, 0 squared plus negative 5, the quantity squared, sure enough, equals 25. And if I use the ordered pair 4, 3, 4 squared plus 3 squared is 16 plus 9, which equals 25. So this equation has two solutions, 0, negative 5, and 4, 3. Okay? And so let's confirm that by graphing. Here's the circle, it's already drawn, and our line is minus 2x plus y equals negative 5. And let's see, we know that if x is 0, y is negative 5. And let's see, well, let's try our second point. If x is 2 times negative 4 plus 5 does equal negative 5, so 4, 3 is a point on the line. And so we can see the 2 points of intersection between that line and the circle. Okay. Let's do one last example of a nonlinear system. And I'm going to back it up a little bit. I'm going to start by doing the graphical method. Okay, because these are easy enough to graph. We certainly know the graph of y equals the square root of x. And let's say it's a 0.42. So it looks like that. Okay. And if we look at the line, this is just a straight line. Notice that if x is 2, y is 0. And if x is 0, y is 2. And so it looks like there is a point of intersection at 1, 1. So we suspect that that's the solution to our equation. Put that, help it get back on track here. There we go. Okay, now let's solve it algebraically and see if that works. And here again, I think I would use elimination, and I would just add the two equations. Actually, I guess I'll subtract. I'll add the opposite. So let's do that. Let's add the opposite. So we get what? Y equals the square root of x minus y equals minus 2 plus x. Okay, and add those. There we go. And if I do that, I get 0 equals minus 2 plus x plus the square root of x. Okay? Now that's an equation. We haven't solved it for a while, but if you remember, when you have an equation with a radical, you want to get the radical by itself. So let's bring the other stuff over to the other side. So one, we add the opposite to combine, or you could have used substitution as well. Either one would work. Secondly, I'm going to solve. Okay, let me bring over the 2 and the x and set that equal to the square root of x. Okay? And so then what do we observe? How do we solve that equation? We square both sides. So if I square that, I get 4 minus, again using our special product, 2 times x plus x squared, and the square root of x squared we know is just x. So I have x squared minus 4x plus 4 equals x, and again I get 0 on one side of the equation. Subtract x, and I get x, what, minus 4, x minus 1 equals 0, x equals 4, or x equals 1. Say, wait a second, I have two solutions, and our graphical only indicated one. What went wrong? Well, remember, when you've got a radical equation, you square both sides, you could possibly be introducing extraneous solutions. Okay? Now, let's see what happens. Let's see how that works and see how we can confirm it. Let's look at the top equation, y equals the square root of x. So if x equals 4, y equals the square root of 4, which is equal to 2. Okay? And also if x equals 1, y equals the square root of 1, which is equal to 1. So we have two possible ordered pairs, 4, 2, and 1, 1. Now we already know one of them is not going to work, in particular this one. And we can confirm that by plugging into the second equation. Okay, if it solves the system, it's got to satisfy both. So if I plug that in, I get 2 for y equals 2 minus 4. Whoops, doesn't work. So this is an extraneous solution. But if I check the second equation, plug 1 for y, and sure enough, that one checks. So this equation has one solution only, or I should say this system has one solution only. And so what you want to be sure of is that you check your solutions. And a good way to do that is by graphing, if it's easy to do. Or we found it two ways. One, by the graph, but also when we tried to plug in to the system, we saw that the ordered pairs that we had come up with, they don't work. Okay? All right. Let's take a break here.